Good morning, students. I hope all of you understood the first two questions from the exercise 8.2. So today we have to continue this exercise, and today we start from the question number 3. And as you see, the question is given here. ABCD is a rectangle and PQRS are the midpoints of the sides AB, BC, CD and DA respectively. And now here we need to prove PQRS. The quadrilateral PQRS is what? A rhombus. So first of all, here the question is same as the earlier one, as not it. So in the earlier case, rhombus given and we need to prove rectangle, and now here this one is totally opposite one. Here in this case, rectangle given and we need to prove rhombus. So before we prove rhombus, first of all we know what is the property of rhombus. So in case of rhombus, all sides are equal. First thing we know, is not it? In case of rhombus, all sides are equal and opposite sides are parallel. And here the angles are not 90 degree. This one is the property of rhombus. So now here, first of all, the diagram not given to us, so we have to draw the diagram by our own. And now here, first of all, what we need a rectangle ABCD. So that's why if you see the diagram here, the diagram is drawn here like in this way. ABCD is a rectangle. So first of all, here ABCD, this one is a rectangle here we drawn, and in this rectangle P is the midpoint of side AB, Q is the midpoint of side BC, as well as R is the midpoint of side CD, and S is the midpoint of side AD given to us. And now after that, if we join these midpoints PQRS, this PQRS is a quadrilateral here, is not it? And this PQRS quadrilateral, we need to prove it is a what? Rhombus. We need to prove this one is a rhombus. All of you understood this one? So let's start now. How can we prove this one? Let's see. Now here, a little bit construction we have to do. Again, if we draw the diagram here, you see ABCD is a rectangle and PQRS are the midpoints here, is not it? Already given this one. And now here the construction is what? First of all, we have to join the diagonal. So in case of diagonal, here diagonal is, first one is AC and another diagonal is BD, as you see here written. So first of all, we join these two diagonals. And in case of rectangle, one thing we know, the diagonals are always equal. Later on we apply this concept here, but first of all you see here AC is the diagonal as well as BD is the diagonal. So now here, first of all, what you have to do, if you see the triangle ABC, this one is a triangle here, this part we have to consider the triangle ABC. In this triangle, P and Q are what? P and Q are the midpoints, as not it? Already we know. So in case of this triangle ABC, easily we can apply the midpoint theorem, isn't it? So if we apply the midpoint theorem, then what we can write? This PQ is parallel to AC. We can write this PQ is parallel to AC, we can write, as well as one more property we know, this length, PQ length is half of this AC, isn't it? So that's why here we write PQ is parallel to AC as well as PQ equal to half of AC. All of you understood this one? With the help of midpoint theorem, we write this. And then we put this one is equation number 1, as you see here given. Is it clear? Okay. Now after that, again, if you see another diagram here, the triangle ADC, this one is the second triangle here. In this triangle, again S and R are the midpoints. If S and R are the midpoints, then what we can write? This SR is parallel to AC. If SR is parallel to AC, then the length of SR is equal to half of AC. Again, the same midpoint theorem we can apply here. and with the help of this one we write here ASR parallel to AC as well as ASR is equal to half of AC. Is it clear? And then we put this one is equation number 2. Understood? Okay. Now after writing this one, now from equation number 1 and equation number 2, that means in the first equation here we get PQ parallel to AC as well as here we get SR is parallel to AC. So from here what we can say, easily we can say, already we have done this type of question, this PQ is parallel to SR. Is it clear? This PQ is parallel to SR as well as this PQ is equal to SR. Why? Because PQ equal to half of AC as well as SR is also equal to half of AC. If both are right hand sides are equal, then the left hand sides are also equal. So that's why here we write PQ parallel to SR as well as PQ equal to SR. Understood? Now one more property we know. Since PQRS is a quadrilateral, and in this quadrilateral we proved opposite sides, PQ and S are the opposite sides are equal and parallel. If in a quadrilateral, if opposite sides are equal and parallel, then what we can say? Then obviously it is a parallelogram. So that's why here easily we can say PQRS is a parallelogram. Understood? If PQRS is a parallelogram, then one more property we know, their opposite sides are equal and parallel, which one already we proved. These two are equal, as well as PS is parallel to QR as well as PS equal to QR we can write. Is it clear? So this one we put here equation number 3. After writing this one, now the next one is you see here. Again, if we consider another triangle here, the triangle is BCD. If you see this triangle BCD, again Q and R what? The midpoints. So easily we can apply the midpoint theorem here in triangle BCD. So what we write? QR parallel to BD as well as QR is equal to half of BD. We can write here according to our midpoint theorem, and then this one we put here equation number 4. So why we write this BCD? Why we take this one? So now here we need to prove all sides are equal. For that reason here we take this triangle BCD. Is it clear? And then we put this one is equation number 4 here. So already I told, in case of rectangle the diagonals are always equal. So as you see here we write the diagonals of a rectangles are equal. So that's why here AC equal to BD. These two diagonals are equal, isn't it? So now in earlier whatever we write QR equal to half of BD. In place of this QR equal to half of BD, we can write AC also in place of BD. If we write in place of BD, we write AC, then QR equal to we write half of AC. And QR equal to half of AC already we proved in equation number 1 and equation number 2. Isn't it? In equation number 1, we get PQ equal to half of AC. In equation number 2, we get SR equal to half of AC. Isn't it? And similarly here in 4, we get QR equal to half of AC we get in place of BD if we put AC. Now from this 4 equation, including the fifth one also, the AC equal to BD, the diagonals are equal. So 1, 2, 3, 4, 5. If we compare all this result, half of AC, they're all in all cases the right hand sides are half of AC. First one is PQ equal to half of AC. Second one is SR equal to half of AC. So from here what we can say? PQ equal to SR, isn't it? And now here after that QR equal to half of AC we get. That means PQ equal to SR equals to, we can say here QR also, because QR is also equal to half of AC, isn't it? And QR means what? QR means already we proved in equation number 3 PS. So in place of QR also we can write PS. Ultimately what we get here, PQ equal to SR equal to PS equal to QR. All sides are here we get equal. So if all sides are equal, then what we can say? PQRS is a rhombus. I hope all of you understood this one. Is it clear? Okay, thank you.